This is a demo on optimal design for assigning treatments to units. And we're going to use the skincare product experiment that we have been following for a couple of weeks now as an example. Remember, we have 6 people, 3 with dark skin and 3 with fair skin. We Each of them has 6 spots where they can apply a skin care product on, and those spots are 2 shoulders, 2 upper arms, and 2 lower arms. Um, we're gonna have a run of 1 week, then we're gonna wait for a while and have again a run of 1 week. So every person will have 6 spots times 2, 12 uh, products applied on their body, meaning that we have 70 experimental units in total. Uh, we have to test 4 products, so 72 divided by 4 is 18 replicates per product. So that's the question: how will we assign products to particular spots on arms and shoulders? We use for that the library ExpDesign, which will do the main part of the work here. And then we have the Tidyverse family, just to help us to get our code running and do some data manipulation. Um, okay, the first part up to here is the creation of the data set or the data frame of all possibilities that the algorithm can choose from. So it will mix and match all the possibilities and find the 72 most suitable combinations out of all possible solutions that we supply it with. And therefore we will just simply create a list of all these possibilities. We have 6 persons, person 1 to 6. We have 6 spots, 3 shoulders, 3 upper and 2 shoulders, 2 upper and 2 lower arms. Um, we have obviously 4 products, and if we make all this combination by this expand grid command, where we have person, spot, and product, we're gonna have a data frame that looks like this. Sorry, gonna view, gonna be easier. That indeed has person, spot, and product, and now it's a bit strangely organized, but person 1 has a shoulder, and we could, for instance, apply product 1 on it. So that would be a possibility that the algorithm could choose from. There's going to be for that same person the same combination, because that person obviously has 2 shoulders. But for that same person also, there should be the possibility to apply product 2 on those shoulders, and so on. So we're going to have in total 144 combinations here. Um, because we have fair-skinned and dark-skinned people, we're going to have the first 3 called dark and the person 4 to 6 called light, to make that distinction. And because we're going to have 2 runs, we need um, all this combination twice. Yeah, so we're going to bind 2 copies of the same data frame and going to put it in again in a data frame with the same name. So from now onwards, all POS has 288 possibilities. That's the preparation of all the combinations that the algorithm can search through. And then we're going to apply these two commands coming from the ExpDesign library. And first, we're going to make the design itself. And for that, we use this function here, opt_fedorov, and um, I will not explain what it exactly is doing. But you see already that the data that it's using, it's the all possibilities that we just have been defining. We're going to tell it that we actually can have 72 experimental units or trials as it's called over here, 72, which is still mentioned over here. Yeah. We're gonna search for criterion or minimize for criterion D, which I explained in the PowerPoint. And we're going to use that to answer to apply it for a model that looks like this, and this is shorthand for um, all main factors: product, person, and spot, and the two-way interactions, so maximum of two-way interactions, so product times person, product times spot, and person times spot. Yeah. So this is the analysis model that we will use once that we have these data, and that we would or have been running this experiment actually, and this is also the model that we use in this algorithm to find the best design. The second step is we using what the output of this here in this part here. So we're going to use the output of this to define how these treatments are separated over to two runs. Yeah, we haven't identifying run here in this formula, and that's what we're doing here. So we have two runs of 36 each. Yeah. Um, there's also and repeats. It means that we're gonna repeat the whole thing 100 times, and so the algorithm each time it goes through it looks for the best solutions, and we're going to do that 100 times, and it's going to look for still the best among these 100 solutions. Right? Okay. Doesn't take too long to find a good solution. And then we have this object BD, which now contains our design. Now, it has a bit of an awkward structure, and therefore um, I'm extracting block one out of this BD. Yeah, I call it run one. Yeah, and I extract B2 out of this or block two out of this BD object, call it run two, and put these things together in order to have a more nicer object to work with. I get a couple of warnings of binding these two things together, but that doesn't matter. And I should now have a design with 72, yes, with 72 units. In order to show you now what is in this design, so this design is uh, again a data frame. Oops. That looks like this first data frame that we constructed, but now we're gonna have only 72 left. We're gonna have it. The algorithm made a selection out of this. What was it? 288. It selected 72 to actually do the test on. To give you a better overview of what is in there, I first give you an overview of by person, spot, and run. So, which is basically the design, and I'm going to count how often that combination is occurring, and I'm going to show it in a pivot table. So it's going to be a little better to view what is happening. And so you see that I have two occurrences, yeah, of shoulder of in row run one for person one, which is logic because person one has two shoulders and both shoulders will be used in run one. So at least already the algorithm was so clever to fill up the entire capacity of units that we have. So there's no person that somehow has three shoulders, or there's no person that had to leave one shoulder or upper arm blank. So everything is nice filled up. That's already a good thing. If I now do a similar thing for, but I include product, you're gonna see you see that the four products now are nicely balanced. So they have all 3 times 6, 24, 3 times 6 is 18, 18 occurrences like we had hoped over here. So we have indeed 18, all of them are 18. In that sense, it's already nice and balanced. But you see that also in this direction. So for the shoulders, there's equal a number of each product on shoulders, on upper arms, and on lower arms, and that also the dark and the light skins are respected. Yeah. So in that sense, it's still very balanced and nice, and no problem. It's less balanced when we take a look within a person, and now I give all um, the products that a particular person will get. And if we look at run one, for instance, we knew already that we were not able to have this perfectly balanced. We have 6 spots and we have only 4 products. So 2 of them will occur twice. So in this case, it is product 1 and product 3. But then in run 2, the opposite should happen. Yeah. So in here, product 2 is appearing twice. It was only appearing once over here in run 1. And product 4 is appearing twice, and it was only appearing once there. So over the 2 runs, again, uh, things are nice and balanced. Yeah. So in total, this is a very nice and good design, and it was probably would have been difficult to find that yourself in a manual way. Now, this problem is still a rather simple one because you could imagine that because 72 is can be divided by 4, there must have been somewhere a good solution for this. Yeah. Now let's make the task a little bit more difficult. If we would have wanted to test 5 products, yeah, would the thing still work with 5 products, and what sort of design would we get out of it? Now, there's nothing much that changes in the whole procedure except that all of a sudden we need here 5 products, but for the rest, everything remains the same. So we're gonna have now 360 possible combinations of these things, and we're gonna run exactly the same ExpDesign functions that we have been running before. Yeah, it goes as quick. I again uh, reorder it with the same problems. I'm gonna see how many rows I have. I have again 72 um, rows in my design. So that's nice. Now the problem will start coming here, or the the lack of balance will start appearing when we do these overviews. Now, this overview is still okay. Yeah, so I still have every single person will have shoulder, upper arms in all runs completely covered only once. Yeah, so left and right, of course, gives a 2. When we do this by product, we will start having a problem because 72 cannot be divided by 5 anymore. So I expect some imbalances here. And indeed, they start showing up. I'll make this table a little bigger. They start showing up. Uh, so I have not nicely everywhere 3 anymore like we had before, obviously because I have fifth product. But if I start making so uh, wait a minute, shoulders, this is a 5, this is a 5, this is a 5, and this is a 5, and this is a 4. Yeah. On upper arms, this is a 5, this is a 5, this is a 5, a 4, and a 5, a 4, a 5, a 5, a 5, and a 5. Yeah. I have one that maybe could have been better. One here, but for the rest, things look more or less um, okayish, or the best we can make out of it at this moment. Um, Again, if I make the an even further uh, drill down or further, then you see that for spots, that was the count I just did, and so I have either 5 or 4, and when I look at skin types, I have either 7 or 8. So nothing that is really um, uh, totally out of balance. Yeah. If I look at a particular person, you will see that I will not have balance anymore. I suppose I have in run 1, I have 1, 2, 3, 2 4s and a 5. And here I have 1, 2, 3, 4, 5, and a 3 again. Yeah. So we have not the perfect balance anymore, but um, everything is still present on every single person in more or less an equal number of times. And that's what we needed this optimal design for. Okay, that's it.